Good evening, friends. Now, in periodic properties, one of the important property, that is ionization energy. Now, I want to explain about the ionization energy. This is the important property you have to remember, because this is one of the main concept in the periodic table. If you take, for example, nucleus, take electron. What is ionization energy? This is you have to remember. This is, if you take the forces of attraction between these two, Q1 and Q2, if you charge, this is positive charge, this is the force of attraction is F is equal to K into Q1 Q2 by R square. The distance between these two, that is, if electrons remove from here to up to infinity distance means atom is a very small size, that is 10 power minus 10 size, nucleus is 10 power minus 15. The small size, the electron remove from just 2 centimeters, then that is called generally considered as a infinity distance. If electrons remove from the atom to infinity distance, then it is called as a free state of the electron. What is the definition of ionization energy in this case? The amount of energy required to remove an electron from this next isolated gaseous atom, from the isolated gaseous neutral, this is also neutral atom, is called ionization energy, denoted as I. The amount of energy required to remove an electron, you have to remove this electron, you have to supply the energy, because it will not automatically, it will not remove the electron from this electron binded with this nucleus. That's why if you want to remove this electron, you have to supply the energy. The amount of energy required to remove, what is the definition? From isolated atom only you can remove. And a single atom, isolated atom means single atom, hydrogen or nitrogen, what will, from sodium, what will be sodium. From isolated atom only you can remove the electron. That is, must be in a gaseous state. In solid state, you cannot remove the electron. In neutral, it is not having positive or having negative. Neutral atom. From the isolated definition, the amount of energy required to remove an electron from isolated and neutral gaseous atom is called as a ionization energy. This is the definition we have to remember. The energy release is in electron volt per atom. We measured in electron volt per atom. And also kilojoule per mole. These are the units of ionization energy. 1 electron volt is equal to 96 kilojoule. This is also 1 electron is equal to 1.6 into 10 power minus 19 coulombs. This is the charge of the electron. 1 electron volt is equal to the 96 kilojoules. Electron volt per atom is equal to, this is the definition, volt per atom, kilojoule per mole. This is the some of the important points we have to remember. After that, successive ionization energy. What is the ionization energy, successive ionization energy? Next I have to remember. If you take, for example, metal, this is the electrons. If you remove one electron from here, then it will form metal plus one more 2 electrons. This is ionization energy 1. If you take one more electron, this is M2 plus, this is one of the electron, this is IE2. If you want to remove this electron also, what will happen? Metal plus 3 plus IE3. This is one more concept, delta H. This is negative. Endothermic. Positive means endothermic, negative means exothermic. It is exothermic reaction or endothermic reaction. We have to supply energy. That's why this is endothermic process. It's not exothermic. This you have to remember. Next, what will happen? After first ionization energy, you can remove easily. Then after that, it will, nucleus is strongly bonded by these two electrons. It is removal is somewhat difficult compared to, you supply more energy compared to this IE1. That's why this is IE2. If only one electron is attracted by this metal positive charge also increases, the electron is single. This is strongly bonded. To remove this electron is very tough. That's why IE3. Generally, IE3 is greater than IE2 is greater than IE1. The successive ionization energies will be automatically increases. This is the point how to remember. Factors affect the ionization energy. Next we have to remember factors affecting the ionization energy. Factors affecting the ionization energy. What are the factors affect the ionization energy? What are the factors are there? First one is atomic size. What will happen? Atomic size. Size means atomic size. If atomic size is increases, automatically ionization energy will be decreases. It's easy to remove. That is, ionization energy is inversely proportional to size. This is one of the concept. Next, nuclear charge. Second one is nuclear charge. If nuclear charge increases, the ionization will be decreases because number of protons increases. It is strongly bonded by the nucleus. If it is difficult to remove the electron, that's why this is nuclear charge increases. Ionization energy also increases, directly proportional. Nuclear charge is directly proportional to ionization energy. This is the concept. Next, third one is electronic configuration. Electronic configuration. Electronic configuration. Generally, half filled means P3. These are two types, D5 and F7. Generally, F is diffused, they not considered. This is the half filled. Next, fully filled, P6, D10. These are fully filled. These will have high ionization energy. Ionization energy will be increases because this is difficult to get stable configuration. That's why this is difficult to remove the electron. That's why it requires more energy. That is ionization energy. Next, another fourth one is shielding effect. That is next one, penetration effect. It's called this penetration effect. Fourth factor is penetration effect. Penetration effect. That is S orbital is more penetrated than D and D. It is close to the nucleus. This it is due to spherical shape. It's penetrating more compared to P, T, and F. This is highest electron ionization energy in case of S orbital. If electron is present in case of P, D, F. These are the four factors which affect the ionization energy. Next, we have to discuss about the how it will change in the groups and trends and periods. Next, this is also important. Next, in case of groups, first you have to take on periods. If you take period 1, generally what will happen? from left to right, the nuclear charge will increases, ionization energy also increases. This is the concept. What will happen in case of period 1? Period 1, hydrogen and helium. Which is more? Helium is greater than hydrogen. General concept. Left to right, nuclear charge increases, ionization energy increases. Next, in case of period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Generally, what will happen from left to right? From left to right increases. Due to nuclear charge increases, ionization energy also increases. This is 1s1, 2p1, first period, period 2, 1s2, 2p2, 2p3, 2p4, 2p5, 2p6, 1s1, 2s2, 1s2, 1s2, 2s1. Small correction, 1s2, 2s1 because 3, atomic number 3. 1s2, 2s2, 1s2, next 2s2, 2s2, 2p1, 2p2, 2s2, 2p2, 2p3, 2s2, 2p3, 2p4, 2s2, 2p4, 2p5 and 2p6. This is the electronic configuration of this one. Here general concept is done, but this is now some of the exceptions are there. Exceptions. What is exception? This is fully filled. This is half filled. That's why this is after the beryllium. Beryllium comes to before, after boron. In case nitrogen jumps to oxygen. What is the correct one? Lithium is greater than, boron is greater than, less than, beryllium is less than, carbon is less than, oxygen is less than, nitrogen is less than, fluorine is less than. Yeah, this is the actual electronic ionization energies of the in case of period 2. Two exceptions are there due to this fully filled and also the spherical penetration power. This boron it jumps to, beryllium it jumps to after the boron. Boron will comes to next. Due to the half filled, nitrogen is jumps to after the oxygen. That's why this is the correct ionization energies of the in case of period 2. This you have to remember. And also one more next period next period and also take period 1, period 2, period 3. Sodium, magnesium, aluminum, carbon, silicon, phosphorus, chlorine, sodium, magnesium, aluminum, silicon, phosphorus, chlorine. Next, argon. These are the series of the in case of sulfur. Sulfur you have to use. Sulfur, phosphorus after that sulfur. Sulfur. Chlorine and argon. General trend is this is 3s2. Next after that sulfur is next which one? Phosphorus is 3p3. Due to this fully filled and this is half filled, this will jumps to here, this will jumps to after sulfur. General trend. Left to right, what will happen? Automatically ionization energy will be increases. But these two are the exceptions. That is sodium is greater than, next aluminum, next magnesium, next silicon, sulfur, phosphorus, chlorine and argon. This is the actual series of the in case of period 3. These two are the magnesium and phosphorus due to the fully filled and half filled. These are the two exceptions. Next, in groups. if you take in groups, what will happen? Top to bottom, top to bottom, top to bottom, ionization energy decreases due to size increases. This is one of the concept. Ionization energy decreases due to size increases, but number of shells increases. That's why. If you take in this case, first group, group 1, lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, strontium, beryllium, magnesium, calcium, beryllium, magnesium, calcium, strontium, radium. Same trend it will follows. Automatically decreases. This is means lithium is greater than, sodium is greater than, potassium is greater than, rubidium is greater than cesium. Lowest is in entire periodic table is cesium. Highest is helium. Highest helium, lowest is cesium. Entire periodic table, highest ionization energy is helium, lowest ionization energy is cesium. This point you have to remember. Next, after group third, some of the exceptions are there. Next, group third, this is very important. Boron, aluminium, gallium, indium, and thallium. This is somewhat exception. Take the graph. This is ionization energy. This is atomic number. You have to find out. This is the W. If you take boron, aluminium, gallium, indium, and thallium. 1, 2, 3, 4, 5. I will explain why because means first one is, which one is highest? Boron is greater than. Next, thallium is greater than. Next, gallium is greater than. Aluminum is greater than indium. This is the series. This is the series means 1, 5, 3, 2, 8 to 4. This is the sequence of the ionization energies of the third period. Why? Because due to the thallium is highest. This is thallium is due to lanthanide contraction. After thallium, it will due to lanthanide contraction. Third period, due to lanthanide contraction, this thallium is atomic size is very poor. Size will decreases due to lanthanide. That's why ionization energy automatically increases. This is due to transition contraction. Means d block elements will be start from India due to transition, due to d block elements enter. That's why the nuclear charge increases. The atomic size will be automatically decreases. The atomic size will decreases, ionization energy will be increases. This point you have to remember. Due to lanthanide contraction is highest in case of thallium. After boron, it will increases the ionization energy. Next, due to indium, due to transition contraction, not indium, this is gallium. Gallium, due to transition contraction, this is automatically after 3D only. No? This is 3D only to start, third period only. That's why due to this transition contraction, this will highest. Boron is greater than, thallium is greater than, gallium is greater than, aluminum and indium. This is the, due to these two contractions, this is highest. Very important. Next, carbon, silicon, germanium, tin and lead. Here only exist in the lanthanide contraction. This is not. Carbon is greater than, silicon is greater than, germanium is greater than, lead after that tin. This is one of the exception. only one, due to this is lanthanide contraction. But in case of due to transition contraction and lanthanide contraction, these two existed. That's why the thallium is highest than gallium, aluminum, and indium. But in case of lead, it comes before the tin only because due to lanthanide contraction. These are some of the exceptions in case of groups. Next, we discuss about the what will happen. Next, we discuss about the successive ionization energies of two oxygen and nitrogen. These also we have to remember. Oxygen. First, we take oxygen and also nitrogen. Comparison. This question also will ask. 1s2, 2s2, 2p4. 1s2, 2s2, 2p3. If you take first ionization energy 1, what will happen? O plus. Yes, that's it, by removal of electron. Next 1s2, 2s2, 2p2. Next you take another second ionization energy 2. This is O2 plus. 1s2, 2s2, 2p2. If you take first ionization energy means this remember of removal of electron n plus 1s2, 2s2, 2p2. Next you remove one more electron. This is IE1, IE2, n plus 2. This is 1s2, 2s2, 2p1. IE1 of nitrogen, IE1 of oxygen, which is more due to this half fill. IE1 of nitrogen is greater than IE1 of oxygen. Next, IE2 of oxygen is greater than IE2 of nitrogen. Why? Because after removal of electron, this will get off field. That's why the removal of this IE2 is greater, more energy required compared to the removal of from the electron IE2 of nitrogen. This is comparison between these two, oxygen and nitrogen, IE1 and IE2, IE2 and IE2. Different. This point you have to remember: half filled or full filled. Next, this is metallic and non-metallic character you have to remember, because what will happen if it is ionization energy less, removal of electron is easily, that is metallic nature. Remove metallic character increases, electron remove easy, that is metallic nature increases, because due to removal of electron easy, that is metallic nature increases means basic nature also increases. Metallic means it is a basic character, easy to remove electron, easy to remove electron. If ionization energy is high, that is difficult to remove electron, this is non-metallic in nature, means acidic character. Acidic character is increases, basic nature increases. In this case, energy is high means acidic character increases. This is generally it will form oxides. Oxides are acidic in nature. This is oxides are basic in nature. In periodic table, what will happen generally? From left to right, what will happen? Ionization energy increases. This is non-metallic character increases. Non-metallic nature increases. From left to right, top to bottom, what will happen? Top to bottom, ionization energy decreases. That's why metallic nature increases. Metallic nature increases because the removal of electron is easy. That's why the metallic nature increases from top to bottom, left to right, non-metallic character increases. This will show the basic character. Acidic nature increases, acidic character increases. Non-metallic means acidic character increases. Here basic character is increases. Basic nature increases. These oxides are acidic, these oxides are basic. This is the you have to remember. If you take for example lithium, next to lithium oxide, lithium Li2O, N2O, sodium, potassium oxide. what will happen? Oxide basic nature. Generally, lithium oxide is less basic compared to potassium oxide. Basic character increases. Next, if you take for example beryllium, boron, next nitrogen N2O5. Acidic nature increases. The oxide is left to right, acidic nature increases. This is some of the characters of this based on the ionization energy we can identify. This is about the ionization energy. Now we close here the periodic table. We discuss about the atomic radius and ionization energy and also the some of the important concept. Thank you.